this for a second. Have you ever looked at a totally dead appliance? Maybe your family's expensive television or that trusty rice cooker that just gave up one morning and ended up throwing the whole thing away. Well, what if I told you that it likely only needed a simple 5-minute electrical fix? Seriously, just think about the sheer amount of money lost and the mountains of electronic waste piling up in our landfills, all because of a single, tiny, loose wire. The crazy part? You actually have the power to fix it yourself.
So, welcome to today's Explainer. I am absolutely thrilled to have you here with me. Today, we aren't just going to tinker around with electronics. We are going to completely master PCB soldering. We're going to permanently upgrade your engineering skills, take you from amateur to professional, and really dive into the true art of meticulous workmanship. Massive, high-energy welcome to my brilliant Grade 10 STEM class. It is so awesome to see all of you here and ready to learn. And hey, before we spark up those soldering irons today, make sure you hit that subscribe button to Jomar Bell TV for more amazing, high-quality, educational content just like this. You definitely won't want to miss what we have planned for the rest of the year. Now, today's core focus goes way beyond just melting some metal on a printed circuit board. We're grounding our entire lesson in the concept of Pagkamasinop. It's this beautiful Filipino value that translates to meticulous workmanship. It's all about taking real pride in your craft, you know? It means getting it right the absolute first time, ensuring your repair is flawlessly safe, prevents dangerous household fires, and actually outlasts the appliance itself.
All right, let's look at today's workbench briefing. We've got Section 1, the Pwede Na problem, Section 2, soldering science, Section 3, the golden rules, Section 4, the meticulous sequence, Section 5, diagnosing errors, and finally, Section 6, assessment and activity.
Okay, let's dive right into Section 1, the Pwede Na problem. Take a look at the Pwede Na repair first. It's a rushed, messy heat application that results in a super weak mechanical bond. A joint like that is basically guaranteed to fail under the absolute slightest vibration or heat. The result? The family gets stressed out, and the TV is broken again. But compare that to the Pagkamasinop repair right next to it. Flawless electrical continuity. Now, why does this matter so much? Because electronic waste makes up a staggering 70% of toxic waste in landfills. And so many of those discarded items just suffer from one bad connection. Your skills can literally save the environment. Moving right along to Section 2, soldering science. Let's talk workbench chemistry. So we don't just use any random metal off the street, we use the industry standard 60-40 alloy. That's a mix of 60% tin and 40% lead. But I want you to notice the secret weapon right in the middle, the rosin flux core. As the solder melts, this flux vaporizes and actually chemically cleans the copper pad in real time. It eats away the oxidation so the two metals can fuse perfectly. It's like magic.
188 degrees Celsius. I need you to lock this exact number into your memory right now. This is the perfect melting sweet spot. See, pure tin melts at a pretty high 232 degrees, and pure lead at 327. But when we blend them together into our 60-40 alloy, the melting point plummets down to 188 degrees. This is a total game changer because it means we can melt the alloy incredibly fast, minimizing the amount of dangerous, scorching heat we expose our delicate circuit boards to.
All right, Section 3, the golden rules. Time to set some strict professional boundaries. Rule number 1 is the absolute 5-second rule. You have exactly a maximum of 5 seconds to complete your connection. No exceptions. If you leave a blazing hot 300-degree iron on a circuit board longer than that, the adhesive resin inside the board literally starts to boil. The copper pad will lift right off the fiberglass, and boom, you have permanently destroyed the circuit. So in, out, under 5 seconds. Got it? Rule number 2, heat the pad, not just the lead. Your iron tip has to touch both the copper pad and the component leads simultaneously. Remember, solder always flows to the hottest point. You should never, ever melt solder directly onto your iron tip and then try to sort of paint it onto the board. Doing that creates what we call a cold joint, basically a useless blob that looks connected but completely blocks electricity.
Now, what's really interesting here is Section 4, the meticulous sequence.
Let's walk through Phase 1 step by step. First, we clean our hot iron on a brass sponge and apply a tiny dab of fresh solder to the tip. Now, you might be asking, why on earth do we tin the iron tip before touching the board? Well, that liquid solder actually creates a thermal bridge, meaning it transfers heat 3 times faster than just dry metal. Next up, you push your leads through the board and bend them out about 45 degrees to anchor the component in place. Finally, touch that tinned tip to both the pad and the lead, applying heat for just about 2 seconds.
And we move instantly into phase 2. With the joint nicely heated up, you push your solder wire right into the heated metals. Again, into the metals, not the iron, until it forms a nice little mound. Now, pay super close attention to step 2 here. You absolutely must pull the solder wire away first. If you remove the iron before the wire, the liquid solder solidifies instantly and your whole wire roll will be permanently fused to the board. So, wire away first, then lift the iron cleanly. And let it cool naturally. Whatever you do, never blow on it.
Next up, Section 5. Diagnosing errors. Time for a little quality control.
So, take a look at the gold standard here. We call it the shiny volcano. It's got this perfect, smooth, concave shape that completely hugs the lead 360 degrees, and its surface is highly reflective and bright. That guarantees maximum mechanical strength. But then, there's the bad blob, or cold joint. It's round, convex, and usually looks super dull. This frustrating error happens because the solder was melted on the iron, not the pad, meaning the heat was way too low. Oh, and if your joint looks dull and grainy, that means the metal's crystallized unevenly, usually because someone accidentally bumped the board while it was cooling down.
Finally, Section 6, Assessment and Activity. Let's see what you've really absorbed today. Let's test your knowledge. Feel free to shout the answers out loud or just lock them in your mind. Ready? Question 1. What is the ideal tin/lead ratio? If you said 60-40, you are totally spot on. Question 2. What happens if you exceed the 5-second rule? Exactly. The resin boils and the pad rips right off. Question 3. What is a cold joint? Yup, it's that bad, blobby connection that completely blocks electricity because of poor heating. Question 4. Why tin the iron? To transfer heat 3 times faster, of course. And finally, what shape indicates a perfect, flawless connection? The shiny volcano. Amazing job, you guys. Absolutely nailed it. Okay, now for our hands-on peer activity. Listen up closely to these instructions. Step 1, find your assigned lab partner quickly and quietly. Step 2, run through your pre-flight checklist. Make sure those irons are safely sitting between 300 and 350 degrees. Step 3, I'm going to hand each pair a sample PCB. I want you to evaluate it together and grade it using that shiny volcano visual rubric we just learned. And step 4, this is absolutely critical. Review your safety protocols. Ensure your ventilation fans are turned on and commit right now to washing your hands thoroughly with soap and water after the lab to remove any lead residue.
As we wrap up the instructional part of today's lesson, I really want to leave you with the true philosophical meaning behind Pagkamasinop as a working technician. Respect the tool, respect the client, respect yourself. You tin your iron before shutting down to respect your expensive equipment. You get the job right the first time to respect the real people relying on you to keep their homes safe. And you strictly follow safety and hygiene protocols to respect your own health and your long future career. Fun fact, top-tier professional technicians spend about 30% of their time just on organization and cleaning their workbenches.
So, I leave you with this final, provocative thought before you hit the lab. Are you ready to stop settling for Pwede Na and start building flawless connections that actually last a lifetime? I know for a fact you are. Get to your stations, work safely, and remember to just keep learning. Don't forget to subscribe to Jomar Bell TV, and I will see you all at the workbenches right now. Let's get to work.